Okay, everyone, let's start the session. I have taken the question number first. Okay, I have taken question number first. A carrier wave of a frequency 1 kilohertz is compared with a reference waveform of plus 2 volt as shown in below. Calculate the duty cycle. Duty cycle means T on time divided by total time period of the output waveform. The following logic given is output 1. It means duty cycle on time if reference waveform is greater than the carrier waveform. It means this means the higher than the carrier waveform, the output is will come when like in this period the output will not come when carrier waveform will less than the output waveform. You want to draw a circuit to expand it. Draw the first one. This is a carrier waveform of 5 volt in the question. This one is a 5 volt and reference waveform of 2 volt. The reference signal, this one is a reference, this one is a carrier signal. And V reference is greater than the V carrier. Out will be 1. It means when this one is this time period. You file one time period because of the carrier signal is repeated from here. It means this one time is on. This one is the total on time. You take it, this one is a T1 time like a T2. And remaining time if you want take like T3. This one is a T2 and T1. And what is the T ratio? D is equal to T on divided by of total time period Ts. Then T on means this one T1 and this one T. Let's check. This one the half time period T by written as this one the T by 2. So total time period of this one same triangular wave. This one T by 2. It means this one is the same as a T by 4. And this one also T by 4. That's when the total time of this one is T by 2. You have required only this time period T1, T2 and T3. T on is equal to T1 plus T2 plus T3 plus this one total T by 4, T by 4 it means T by 2. Oh sorry, this one is T3 only. This T2 is not coming in the T on time period because this one is the off time period. This T1, T3 and T by 2, but the T3 time period is equal to T by 4 minus of T2. That's why I did a T2 here because of this one total time period is a T4. Yeah, sorry, T by 4, and this one is a T by 4. This one is also T by 4. T by 4. Total is T time period. Then T2, T3 is a T by 4 minus of T2. If you will find the T1 and T3, then you can find the total on time of this waveform. And what is the T1 time? This one, it means if you have this line equation of this line equation coming from the going from the origin, then you can take as this only T by 4 total time period for this section. Then what is the line equation? Line equation is a 5T divided by f Ts by 4 total time. Like y axis total divided by x axis y2 minus y1 x2 minus x1, where x1 and y1 is 0. It means y axis of waveform divided by x axis total time period into x time. If you take in the voltages, then this one is at last time 5 minus 0 divided by Ts minus 4 minus 0 into T. That's why we written as 5 divided by Ts by 4 into T. Line equation of this one from 0 to T by 4 this time period. Then what is the T1? At T is equal to T1, V reference, V carrier is equal to 2. It means at that time. This one is a carrier waveform. So is like a 5T by divided by Ts by 4. This line equation. Line equation is same as when this one is value is 2. The time period is T1. That's why you can say that 5 T1 divided by Ts by 4 is equal to 2. You can find value of T1 time. into 2 by 5.
Four is there, no, sir. Ts by 4.
Yes.
No,
Oh,
sir. Here
sorry,
the
sorry,
Ts.
sorry, sorry. This one 2 by 5 into Ts by 4. 2 by 5 into Ts by 4. Okay.
Okay.
The next section for T3 to T2 time. T2 time. What is the line equation of this one in this section? Same as linear line equation starting from the y of mx plus c, like where c is 5 plus 5. Then you can say 0 to 5 divided by of same time period, Ts by 4 minus 0 into T minus, so what is this one, T plus of 5 is y of mx plus c. There is, where is m is this one, slope of this one. Then you can say there's 5t divided by Ts by 4 plus 5, this equation. Then what happened is at t is equal to t1, t2, at this time period, same thing as t2, the voltage drop 5 to 2 volt. Then you can take as t2 is equal to t2 minus 5t.
Sir,
So yes,
the equation has to be minus 5 by Ts by 4 into T minus T by 4, right?
t minus t by 4
Yeah.
in this
Yes, sir. Instead minus 5 into,
yeah,
instead of T, we have to write T minus T by 4, right? Because it is
no no
on
no
the curve.
no total time period for this section. If you want to find this line equation, then what will you want? A y-axis divided by total x-axis. The x-axis total time period is t by 4, this one.
Okay.
And y-axis
But it
is,
is shifted by,
yeah, separated is a t by 4. But to take only this section only. Assume this one like starting from origin. Like that's why you can find a section by section line equation. This one
okay.
time period is a ts by 4. This one is 5. If you want this one line equation,
That is okay, sir. We
okay.
can proceed here.
Yeah, that's why to find 5t divided by ts by 4 plus
Yeah.
of where is at 0
Yeah.
origin,
5.
that is the value of y-axis. This one 5. Thus t2 at time t2, this one is value is 2. Then what is the value of t2? This one is going there minus 3 by, so minus cancel out. So now like minus 5 t2 divided by ts by 4 is equal to f minus 3. Minus cancel out. Then t2 is equal to 3 by 5 into ts by 4. Then what is the value of t3? You have required a t3 value time. For t3 it means t square by 4 divided minus t2. This one, what is t3? The total time is Ts by 4. Then Ts by 4 minus of T2 is equal to T3. Ts by 4 minus T2 is equal to T3. And T3 is Ts by 4 divided by 4 minus of T2 is 3 by 5. Ts by 4 is equal to 2 by 5 into Ts by 4. And duty ratio or duty cycle is equal to T on divided by Ft, just total time period. Then T on is T1 plus T3 plus Ts by 2. This total time period on this one T3, this one T1. T1 plus T3 plus Ts by 2 divided by Ts. What is T1? T1 is 2 by 5 into Ts by 4 plus same is 2 by 5 Ts by 4 plus Ts by 2 divided by total time period. Ts cancel out, all of 2 by 5 is 1 by 5 is 1 by 2. The total 7 by 10 is equal to 0.7 in the duty cycle. Sorry. Is okay, everyone?
Yes, sir.
The next question, for the converter given figure, switch Q1 and Q4 kept on for 20 milliseconds and Q3 and Q2 and Q3 are kept on for next 20 milliseconds. Like a Q1, this one, and Q4 is on. So what is the equivalent circuit when Q1 and Q4 is on? It means this one switch on, this like that. VAB, you can take it this one. VAB plus or minus AB is given. VAB means this one is positive, this one is minus negative. VAB. When Q1 and Q4 are on, then what is the VAB? You can apply simply KVL, find out plus VCC. This one is on. This is the load plus VAB. Whether this one positive, this one negative, connected to the source. The next 20 milliseconds, when Q2 and Q3 is on, Q2 and Q3. Same circuit looks like that. This one same as VAB. By reference, then what is the VAB at this time period? This one positive connected to the negative, and negative connected to the positive. Here positive connected to the positive terminal, negative connected to the negative terminal. That's why this one is a plus VCC. And here positive connected to the negative, negative connected to the positive. That's why this one is the minus of VCC coming in the output. This one like if Q1 and Q3 on, this one Q2 sorry, Q1 and Q4 on, Q2 and Q3 in this time period. What is the output on Q1 and Q4 on? This one is the plus VCC. Q3, Q2 on, this one is the negative of VCC. This will finally convert to the output plus VCC and minus VCC. Resultant voltage waveform across A and B. Plus VCC minus VCC. This is not a sinusoidal. It is not mentioned in the question. Like VCC is mentioned, it means this one is the symbol of the constant DC voltage. This is not mentioned is the AC source. That's why you can't say this one is not. Triangular also not mentioned, that plus VCC, it means this one is a positive, this one is a negative, and this is a constant voltage. That's why this one is correct. This one is also not correct because of the this one pulsating pulses come in the output, but here is a constant turn on for 20 milliseconds. This is not a pulsating on. If this one is a pulsating out 20 milliseconds, that in that time this will come in the output. But here is on for 20 millisecond and off for 20 millisecond, and this one Q2 Q3 on next 20 millisecond and off for next 20 millisecond. And output is coming like that. It is continuous on. If this one is a 20 millisecond is a ripple in pulsating, like 2 millisecond or 5 millisecond, then you can on off like that in 5 millisecond. In that condition, this will come in the output. But here clearly mentions that 20 millisecond is kept on and 20 millisecond is kept off. In that time frame, this 20 millisecond is on, and this one is off. This one is Q1, Q4 off, Q2 and Q3 on. The question B is correct. Next question given is consider circuits on below and answer the question. Third and fourth. Like simply connected two capacitor in series. And what is the voltage division of this one? It means this one is question number third is given, like this one on, this one is off, means resistance will be not come in the picture, and this is on. Then what is the voltage division of V1 and V2? Anyone guess? This is the simple question.
We have to apply the capacitor potential divider.
Yeah. Simple, you can apply capacitor potential divider. This one is 16 volt. You can written as this one is Vs equal to 16 volt, V1, V2. There is a C1 as C2. If you want this one to convert in Laplace, then what happens? This one is Vs by S. This one is 1 by Sc 1, 1 is by Sc 2. Then you can simply apply a voltage divider or rule of impedances. Then what is the V1? Now you can find the current, and after that multiply by impedance and you find the voltage. V1 is equal to given a total voltage into same impedances 1 by SC1 divided of total impedances 1 by SC1 plus 1 by SC2. And what will the V1 be into Vs by S output voltage 1 by SC1, here is SC1 plus SC2 divided by F. You can take S common, then find S C1 into C2. You can this one is cancel out, and this one C1 and this one C2 C1 cancel out, and find V1 is V by S into C2 divided of C1 plus C2. This one in the frequency domain or Laplace domain. Then what will the time domain is equal to V divided by F C2 divided by C1 plus C2. Same thing we apply for the V2. Then V2 is V into C1 divided by F C1 plus C2. It means if you have a resistance divider, voltage divider from resistance V R1 R2, then you find that V1 V2. V1 is the same impedance multiply R1 divided by of R1 plus R2, and V2 is equal to V into R2 divided by of R1 plus R2. But in place of resistance, you replace the capacitor, then you find like a V, the same thing opposite this one. V1 is multiplied by of C2 divided by of C1 plus C2, and V2 is equal to V into C1 divided by of C1 plus C2. In case of capacitor, the voltage divider rules are changed. Here it means this one is the opposite of this one. Then you can put the value and find the value of V1 and V2. And what is the V1 voltage? Total voltage is 16. C2 is 3 microfarad. C1 plus C2. C2 is 3 microfarad. C1 and C2 is 3 plus 5, 8 microfarad is equal to 6 volt. Then V2 16 into 5 microfarad divided by F 8 microfarad is equal to 10 volt. It means 10 volt appears here and 5 volt appears here. 6 volt. Total 16 volt. Then the next question is given like let's see, initially S is on and the circuit was made to reach its steady state. It means the voltage steady state voltage is 10 volt of V2 and V1 is 6 volt. Steady state value, it means capacitor is the open circuit and all inductor is the short circuit. That's why if a capacitor is given open circuit by connected not flow, then total voltage appears on the capacitor. Both capacitor 6 volt and 10 volt. It is the current of IR in ampere 2 microsecond. After 2 microsecond, the switch is on. It means what happens if this switch is on and at steady state, when this one is off and this one is on, until you charge for the 10 volt and you appears the resistance value is given as 10 ohm. Then what is the value of current flowing through the resistance at 2 microsecond? After 2 microsecond, what is the current equation in the capacitor? You know about
Sir,
yeah.
now both that S and S bar are on, right?
No, can the S1 S bar both can't on at the same time because of this one S and S bar. If you given a S is 1, then this one is on, this one is off, and as go to the 0, then this one is on, this one is off. In second
But
time,
in the question,
question number second, then this S bar, this one is on, this one is off.
okay, that here they given like initially S was on.
No, this one is just a bar. I think there's some displays the character. This one is a bar is given. Yes, bar is
No,
on.
sir, here at the start, let
No,
initially.
let's initially S is on.
Uh,
But after the
okay.
reach the steady state, it means this one is off
Hmm.
and this one is on.
Okay.
The meaning of this question like that.
Okay.
You can't keep on for both switches at the time.
Okay.
No current across the capacitor. Sorry, in RC circuit, V by R e power minus of t by tau when capacitor is initially charged. Capacitor is initially charged, or you can say like when capacitor is discharging current. Because of here, when capacitor is on for 10 volt, after switch is on S bar, and that time the capacitor will be discharged. This one the time the current equation of this one V by R into e power minus t by tau. But when charging, this one is for the discharging current. You can say this one is discharging current equation. But a charging current equation is IR is V by R into 1 minus e power minus t by tau, or on time period. This one like that. And at that time, this one current flow like that. This one is initially charged capacitor, right? After the switch is on, this will be discharged like that, and at steady state will be current will be 0. And tau, what is a tau? Tau is the time constant of this one this circuit. Because of the resistance connected across this capacitor only, that's why you can take a time constant of RC2 only. Resistance is given 10 ohm, then what is tau? 10, and C2 is given 3 microfarad, total of 30 microsecond. Then what is the value of current at t is equal to 2 microsecond? Asking in the question. Tau is 30 microsecond, t is 2 microsecond, voltage is given 10 volt. Now we find voltage at V2. Then what is the current of IR? V2 is a 10 volt. Divide IF ampere, 10 ampere current. E to power minus of t, 2 micro is 10 to power minus 6 second. Divided by tau of 30 into 10 to power minus of 6. Find e to power minus 1 by 15. You can solve this one in calculator. So it will be 0.935 ampere. It means at starting it will be 1 coming like that. This one is a 1 ampere current at starting IR, because of at starting initially t is equal to 0, then this will be 1. IR is equal to V by R. When switch is on, just on, this will be 1 ampere. Starting from 1 ampere and decreasing like that. At 2 microsecond is 0.935 ampere. 2 microsecond, so 0.935 ampere. Next question is like consider the following circuit, 2 RC circuit, 2 RC parallel circuit and one as series resistance. Which of the following block diagrams is correct for the model based simulation MATLAB? Like this one. V output here, V in input here, I input here. All of you given in a S domain. It means we first of all find the value of Vn with respect to all the resistance and capacitor, like a voltage equation V and something. In that condition you can find this block diagram. You simulate in MATLAB directly in this circuit. If you look here, you can see this circuit is same as like a battery equivalent circuit diagram with a 2 RC parallel circuit. You know about the battery model as one RC circuit. This one is simple circuit. This one is internal resistance. This one is the time constant of battery. Output. So this one is at PT terminal voltage. Battery is equivalent circuit like that. The same is thing given here question. The 2 RC parallel circuit and one internal resistance of R3. Then he asks about the block diagram. Let's find it.
Sir, this RC,
Yeah.
you have said in the equivalent circuit of the battery,
Yeah.
we'll have one internal resistance and then one RC in parallel.
This one is a simple but one RC. You can apply more than one RC. 1, 2, and n number of RC parallel circuit to implement as equivalent of exact like that. If
Sir,
you
this is
irrationally
okay.
less, if you take a more number of parallel circuit.
What is more, sir? When you have to take more?
Yeah, you can connect it the number of RC parallel circuit. If you take more than one, like a 2, 3, and 4, then n number of parallel circuit, RC parallel circuit, then you have find the exact equivalent circuit of the battery.
But
Then either of this one is very less, and this is same circuit as a battery, behave like a battery.
what is the significance of this RC? What it represents?
This one is the time constant of battery, like the
Charging time.
charging, discharging. Yeah,
Okay. No, but battery will
like
have a different time
battery.
constant, no,
No, no,
for
no.
charging.
Battery have some response time. Na? If you connect the
Ah,
battery, the battery does not flow the current suddenly.
okay.
It have some response time. After that,
Mhm.
you give the some current. You can't flow current suddenly from the battery.
Oh,
You just connect the load, then that it does not flow the suddenly all of current. It will take some time in millisecond or microsecond, like that. After that, it will flow the whole current.
oh.
This
That time is
that
delay.
time, yeah, that time is represented by the RC circuit.
Okay. But it will not be contributing to any energy dissipation, internal resistance.
No, no, no. This one is only equivalent circuit, not exact. This one.
Okay, okay,
Hmm.
okay.
But you
Okay,
have
sir.
some chemical reaction, like chemical equivalent. This RC represents only for the chemical equivalent of the electrical circuit. It is not the exact of the battery circuit.
Mhm.
This one is the equivalent circuit of the chemical reaction of the battery from by the electrical circuit.
Okay, sir.
Supercapacitor have a very less response time with respect to battery, but battery have some response time. This one is a V in, this is a V output voltage. This one R3, R2, and R1. If you want to draw this one, can you transform the Laplace, because of all of quantity is given in the answer is in Laplace domain, frequency domain. That's why I have taken this one is a Laplace SC1, this one is SC2. Not this an output voltage. They both are constant. That's why I have taken the same as V in and V out. This one is the input current. And what will be the impedance of this one? Calculate the impedance of this one first. The parallel circuit, impedance of RC parallel circuit. C1 is
Yes.
R1
Uh,
divided of 1 plus SC1 R1. If you calculate this one, here, parallel of this one, and multiply up 1 or divided by f S C1 and R plus by SC1. Z1, Z2 divided by Z1 plus Z2. We take SC1 common, SC1 S1 cancel out, and find like R S. This one is pivot R1, then take R1 S R1 C1 plus this one. Same thing, this one R2 divided of 1 plus S C2 R2. This one input current I. Then simply apply a KVL in this circuit and we find the V output. What is V output voltage in this? V in this one minus of all voltage drop in the output voltage. V in minus I in R1 divided by 1 plus SC1 R1 plus R2 divided by 1 plus SC2 R2 plus R3. V in minus of I in if you take as SC1 R1 is common like that, you not will find. So V in minus of I input, this one current is positive. Well, condition you can say that V in, okay, this one V output, all of input here current multiply of this one I input into R3 V in, this one is to come here the positive and this one is negative output. Then how will be the output here in this? You can say that V in, this one is positive plus V in, this one is negative minus of I in into R3. Then this one is the parallel graph, parallel line, and this one is the feedback of this one. You can calculate and how to find from this one. Sorry. From the here you can do this I into R3. This is okay. Minus sign is here. That's why you can say V in positive plus of this one minus I into R3. Then this one is a forward path. After that adding here forward path multiply of R1. This is minus, it means minus of I in into R1 into multiply of this one. Can you solve this one as a feedback loop? Loop gain multiply of this one. Like if you have a transfer function given a GS and this one is a feedback minus feedback, negative feedback, this one is HS. Like that. And what is the equivalent block diagram, block reduction? From block reduction, you can see that this one is a GS 1 plus GS HS. From block reduction technique, if you want to combine this one with feedback system, then you find the GS, this one, divide by if you have a negative feedback, then this one is a positive. We have positive 1 plus the one HS, GS, HS. I think you have read in the control system. No? If you have this one forward block, this one is a feedback path. You want to combine this one in one block, then you find the GS divided by 1 plus GS, HS. Same thing you can apply here. So if two blocks are in cascade connection, you can simply multiply this one 1 by R1 into S divided by 1 plus 1 by R1 into S into Cm. This one minus of this one R2 I in into R2. What will be this one? 1 by R2 into S divided by 1 plus 1 divided by R2 into S to of C2. But in question, this one is not like that. So like that, I made this one R1. Okay, take R1 common. Take 1 by R7, C1 is common. 1 by S C1 R1 divided by 1 plus 1 divided by S C1 R1. Okay, written like that. This one I in into R2. Same thing you can apply here also. C2 R2 divided by half 1 plus 1 divided by S C2 R2 minus of I in into of R3. But in block option 1, the block reduction is 1 by R1 into S divided by 1 plus 1 by R1 into S into C1. It does not look like that system, like 1 by S C1 R1 1 plus S C1 R1. So the not match. That's why this is not correct. Comes the second point. Same thing. This one is V in, V output plus V in minus of I in into R3. Then reduce this one. The output is equal to V in minus of I in into R3. From here, same I in multiply by this one minus of I in into R1 minus of I in into R1. Feedback is 1. 1 multiply by this one 1 divided by of S C1 R1 divided by S C1 R1 by 1 plus GSHS 1 plus GSHS. Here the feedback is going to 1. That's why HS is equal to same as GS divided by S C1 R1. Then next negative here also, but sorry, this one is the positive feedback. Yeah, if this one is a positive, then this one is not coming the positive. This one is a negative block reduction. Negative feedback. This one is a positive. Being positive, this one is a negative. And into R2.
This is not the answer.
Yeah.
No, this is not the answer.
Yes. This one is not answer. It will looks same like that, but difference only is the positive and negative. This positive is shown in the control system. This one is shown is like a negative feedback or positive feedback. If this one is a positive, it means this one the system will be negative feedback. If this one is a positive and the negative, it means this one system will be a positive feedback system. But here it will be positive, it means the whole system will be in negative feedback. This one is positive feedback, and this will not conduct. So negative feedback okay, but this is a not match element. Then what is C? Option C. Take as a V output is equal to V in minus of same I in into R3 So negative, this is negative feedback minus of I in into R1 1 divided by S C1 R1. This is negative feedback, it means 1 plus 1 divided by S C1 R1. Same thing for the R2 minus of I in, this is a minus, that's why this is a minus, into R2 1 divided by F S C2 R2 by 1 plus 1 divided by S C2 R2. This one is the max exact like this one. B in, B output is same as B in minus of I in R3 here, I into R1 1 by C1 R1 plus 1 by C1 R1, like 1 minus I in into R1 1 by divided by C1 R1 divided by 1 plus C1 R1, both are same. What is option D? This is also same, but this feedback is coming from here, and this feedback going from here. That's why this is also not correct. This one is just correct option. This one is incorrect because of the positive feedback. This one is not correct.
Sir, can you show the D option once?
Yeah, this is correct. D option is feedback coming from here to opposite.
Oh, okay.
That's why this is not correct. Everyone know about that. This one, if you have a negative feedback system, the what will the final transfer function? This one the error input minus of output. This will be in error signal here. This one you have plant. So you plant GS. This is negative feedback. Mainly this feedback is just like a sensor multiplier. This one gain multiplier system gain feedback to convert the output to same as the input time. Then what will the total transfer function? Transfer function is a CS divided by RS, output Laplace transform of output divided by Laplace transform of input. Then what will CS? CS we can written as ES, error signal, into transfer function. Plant transform ES here is coming ES into GS, same as CS. Then what is the error? Error is input minus divided by RS minus, this is a negative terminal, that's why minus HS into CS, because this one is CS. C is coming with feedback. gain. That's why this one HS into CS coming in the input side, RS. Here is RS minus of HS into CS. If feedback is a unity, feedback gain is unity. It means HS is 1. And that time RS input minus output is the error. Error is the same like that. But if feedback gain is something, that's why they multiply by HS, feedback gain. Then you can replace CS, ES here. Now CS is equal to ES. ES it means RS minus of HS into CS GS. RS into GS minus of HS into GS into CS. So, okay everyone till here.
Yes, sir.
You can transfer this to CS at one side and take a CS is common, then 1. This one negative comes to the left hand side, this one is the positive, only HS and GS is remaining. CS will be common here, is common. Then this one is the RS into GS. Then what is the transfer function? Transfer function is equal to RS output as CS divided by input. RS, CS same thing, divided by RS, and what will find? Finally, GS divided by 1 plus HS into GS. It means you can retain it directly. You can reduce the block CS RS into CS, so GS divided by 1 plus GS HS. You can reduce this one block that in the only of this one. Multiply of the RS into here, this one is the CS. Now what happens if this one is positive? This is positive feedback. Negative feedback and positive feedback. If this one is a positive feedback, it means this one is either is RS but plus of this one, plus of this one. That's why this one is a positive. This one is positive, positive. If you in the final equation, this will be negative. You transfer the input side. That's why this will come in the negative in positive feedback and positive in negative feedback. Okay. We'll take a question. Next question. The efficiency. If you understand the model of simulation model of this circuit.
Yes, sir.
Third one is like you can relate the circuit from the KVL, only mathematical equation. This one the KVL is same as the mathematical equation, and we relate this one is transfer in the block model based. Same behavior. This behavior is the same. If you put this one value R1, C1, and R3, all of this one V in, V I in, and current will flow to find the output voltage. The efficiency of this converter, following DC converter, considering the on-state resistance of switch is on is given here, and the DC resistance DC of the inductor. This one is given. Then what will be the efficiency of this converter? The option I think some displaced from original position. I written separately. Option A is equal to efficiency 1, B efficiency 1 plus RL divided by R plus R on divided by R, and C efficiency is 1 divided by F1 plus RL divided by R plus R on divided by R. D option is efficiency of 1 divided by F1 plus RL divided by FR plus D R on divided by R. You can realize this one converter only for that taking the option. What?
The D comes to the
Yeah,
bottom.
yeah.
So in the fourth option D,
Yes.
the in the denominator the D comes in the bottom, it seems.
Yeah. Multiply of this one D R on.
Okay. But in this, okay.
D R on
Hmm.
divided by R. On the option you can realize that if R1 and RL is not present in the circuit, then what happens? Efficiency is 100%, because if this one is not present, so 0 0 in the all option, efficiency is 100%. It means you realize the ideal buck converter, and this is not there. The efficiency is 100%. And efficiency, you know about the efficiency is output power divided by the input power. Output power is V output, I output, input power V in into I in. In DC case, AC same is the AC, but some power factor of course. But in DC, V output, I output divided by V in I in. Here output current is same as V output divided by R. And duty ratio also given DT, same as duty ratio. You know about that. First of all, find the value. What happens if switch is on? Buck converter and switch is on, the circuit is like shown like that. So like that, V in minus R on RL, this one is C, R on, this one the current of I RL, L, VC, this one is the C, R, V naught, IR. And what is the VL? You can apply KVL in this circuit like that. This one is the V output. At that terminal, take a directly V output. Then we find that V in is equal to IL into R on this voltage drop plus this voltage drop IL into RL plus this voltage drop VL plus of V naught. Then what is the VL? Inductor voltage V in minus of V naught minus of IL R on plus RL. Written like that. Open switch is off. The switch is off. And this one will be off. Current will not flow from here. Current total current flow like that. Diode will be turned on. The same V naught or IL, BL, and RL. Write the KVL in this equation. By KVL in the circuit, by KVL starting from here, VL plus this one IL into RL plus of V naught is equal to 0, and what is the inductor voltage? VL is minus of V naught minus IL into RL.
Sir,
Yes.
the inductor voltage polarity will change.
Yeah, polarity will change, but in difference we take only difference, not a polarity change. All type.
Okay.
Take a reference in every equation where you find, then take as a reference only. Sign is a reference only. Negative signal by understanding of yours.
Okay.
But everywhere if you take an equation, mathematical equation, then take only by the reference.
Okay. For the capacitor current also same thing.
Same thing. So everywhere you take only reference. Like that. So I see, so I know. By volt second valence equation, VL into T on time plus VL to T off is equal to 0. And T on, this one is when switch is on, dV in with this one, written here, left right here, D into V in minus of V output minus of IL R on plus RL minus 1 minus D. This one is a minus of V naught minus IL into R on. Okay, RL. V in minus of V naught minus IL R on plus IL RL. This one multiply by D here, and 1 minus dt minus of this one is equal to 0. Then find the voltage, output voltage. So dV in minus of dV naught minus of d IL to R on plus RL minus of 1 minus d, it means this one minus will be the positive V naught minus of IL into RL and multiply by 1. We multiply by minus d, then minus of V naught dV naught so this one is a positive, not negative. The positive voltage.
So this inside also 1 minus D into
V in this is a negative, this is negative. So if you take a negative common, then but this will be positive.
positive.
Okay. So minus of V naught minus of IRL, this one will multiply by of the D, then this will be positive. This will be also positive, D IL into RL is equal to 0. Then dv0 is equal to cancel out, and dil into RL, multiply by this one minus of dil into RL plus of dil into RL. This will be also cancel out, and final of dv in minus of dil into R on minus of v naught minus of il into RL is equal to 0. In a buck converter, if you take capacitor current is on IL, then IC is the same as IL minus of I naught, V naught I naught. This one is IL minus of V naught by R. In this condition, when switch is off, in that condition, this is also same as, because of this one IL, IC is IL minus of I naught. If you apply a current second, balance equation, DIC plus 1 minus D, so DTIC 1 minus DTIC is equal to 0. The switch is on, then DIL minus of I naught plus 1 minus DIL minus of I naught is equal to 0. You take all of average, you take as a capital is average of this one DIL, average value minus of DI naught plus of IL minus of I naught minus of DIL plus DI naught is equal to 0. This will be cancelled out. IL is same as of I naught, and I naught will be same as V naught by R buck converter. That's why IL here also the average value. That's why I replace the IL is same as capital IL is the average value V naught by R, because of I naught. IL is same as the I naught minus of DIL R on plus RL minus V naught is equal to 0, and dV in d of V naught divided by R on plus RL minus of V naught is equal to 0. V naught common, and the V transfer to the right of side. Then find V output is equal to,
So the D has to be multiplied in.
sorry, D will not multiply by all. This will be different. To D into R on minus of IL into RL V naught into D R on divided by of R V by R is taken here. V naught a common, then you find, so minus V naught common, find 1. This one is 1 plus RL divided by R here plus DR on divided by R is equal to, this one is minus of dV in, minus cancel out. Then we finally find the output voltage as dV in divided by 1 plus RL by R plus DR on divided by R. reduce the size of this one.
Sir,
Yes,
in the previous slide, we have written equation for current second balancing.
yes, yes.
Sir, actually, for a buck converter, the waveform of the capacitor current will be a triangular waveform.
Yes, sir.
But for that, can we write like this, sir? D into IC, because IC is not a DC value; it is not a constant for DTS.
Yeah, this one is for the constant. This is the average of this IC at a time period of on, at time period of off.
Okay.
If we add this both this one, the total current will be zero. This is not a triangular waveform equation. The IC.
Okay.
The, this is a total IC means current, total charge.
Okay. Charge.
Charge should
Okay.
be same from charging discharging. That's why it does not change in the charge. It shows like that current second balance. It means charge balance. When water will be charged in the positive direction, then same as it will discharge and when switch is off. When switch is on, then this current flow like that, the charge one. When switch is off, then IL and IC both are supplied to the load. At that time, both are the discharge. The capacitor discharge like that. But when switch is on, the capacitor will charge like that. The charge and
Yeah, that's
discharge, the
yeah,
charge,
that is okay, sir.
yeah, charges will be same.
But
Now, what the efficiency is V output and I output divided by V in into I in. Now, what with the input current? I input can be written as when switch is on, then same as the IL current, average inductor current. When switch is on, then I input current flow. When switch is off, the input current will be zero. In that condition, you can say that the I input is same as the D into IL. D is due to this. When switch is off, on, then current IN will flow. When switch is off, then current will not flow. Then you can write the average of input current is same as the D into IL average output. And D into IL is the same as the output current. You replace this one I in DIN. V output is equal to D V in divided by of 1 plus RL divided by R plus D R on divided by R. This one will be V output into V output into I output is same divided by F here V in and I in is equal to D into I naught. This will be cancel out. This will cancel out. This will also cancel out. Final efficiency is 1 divided by of 1 plus RL divided by of R plus D or on divided by of R. If you have now, if you have not inductor resistance and switch on resistance, then the efficiency of a converter is 100%. But RL and RN, switch resistance and inductor internal resistance RL, both are very less with compared to the R. That's why the efficiency of the converter is very high, like 90%, because the RL is very less of inductor current in a milliohm. I think in milliohm. This one RN also in milliohm. Duty ratio is less than a 1. Resistance or load resistance is it will be more than a 1 more. Then that's why the overall resistance overall efficiency is the increase in the converter, the move like 90% or 95%, some of the cases is the 98, 97 like that.
Sir,
Yes.
sir, because of that resistances in series with the switch and diode,
Yeah.
uh, only it looks like only the voltage is getting affected. The
Yes.
current is not about the current doesn't seem to be get affected.
Yes. 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 The,
Sir, what is the reason? Because
no, no. Think like that. Na, if a voltage reduce,
uh,
output voltage will reduce. It means the same output current will be also reduced. Na,
uh,
that's why input
okay,
is not variation. Looks like in variation. Input output current. But in practical cases, the if voltage output voltage reduced, that means output current also reduced. Yeah,
but the relation between I naught
yeah,
and I in remains same.
yeah. The relation is the same.
Okay, only the voltage relation gets affected. V naught by V in.
Yeah, yeah. Because the voltage drop across it.
Uh,
All of component current connected like in series only, because if switch is on, then all of connect in series, and switch is
mm,
off, then this will be in series,
mm.
and that's why the voltage drop is reduced. Voltage drop is more. The output voltage will be reduced.
But actually, the output current will reduce, but the relation between I naught and I in remains same.
Yeah, remains same. Yes, yes. Okay. I have a question related to the buck converter. It's asking about the duty ratio. I'll have to know a small signal analysis. I think I teach once, I think.
Yeah, last class is some perturbation.
Yeah, yeah, yeah. Small signal losses are doing for the finding the transfer function of any converter. Basically, for it used small signal losses to convert the non-linear to the approx linear. Like that, if you have a quantity, this is the not non-linear quantity, non-linear form.
Yes.
If you want to convert in a linear, that means do a part wise of this one. Take a small of signal like that. This one is a small of part one. This one you can say like a linearly. This one because of the non-linear, not non-linear. Total is a non-linear, but you can convert it a piecewise linear. This one is a linear like that. And this one is the small of this one. Then
For sir, for each of that period, we have to write the transfer function.
no, no, no. Because of this one is a variation is very less. Like if you talk about the inductor current, we have like that variation of IL into this one is the average of IL. The current variation is I minimum to I maximum. Delta IL is know about 10 to 40% maximum. 40%
Mm.
of I naught will take it, but not 40% will take in the practical cases 10 to 20% only. And this variation is very less. Then if this is a I naught, suppose this is a, in output current I naught and output voltage V naught. This will be constant. Then we can say that this is the DC value or pure DC But in practical cases, this is not a pure DC. It has some ripple in output voltage. If you have a ripple in output voltage, then the output current also same as a ripple. And output current in a buck converter ripple is same as the input current ripple. Sorry, inductor current some behavior is come in the input current. Sorry, in inductor current. And this ripple, you can analyze the ripple of this one is behave like an AC signal. That's why inductor will work on DC signal, DC voltage or DC supply, because of the this one make you make as an AC in inductor current. Because if you have a ripple in this inductor current, then it means there are some AC signal. DC is the pure DC, like that. This one is the DC signal. DC output, it means the frequency will be 0. But here,
Sir,
if you have a ripple, yeah.
no, sir. Here, along with DC, we will be having switching frequency harmonics, which means if suppose we are switching the buck converter at 10 kilohertz,
Yes.
so that the sinusoid at that frequency will be here. Is it, sir?
Yes, same frequency. If you have 10 kilohertz, it means that this one, total time period. So you make
Okay.
you make a AC signal and AC signal to the inductor current by the frequency, by the switch the inductor current on and off. If you not working in a switching condition, it means you kind of, if you just imagine if you apply as a constant DC to the input, you can connect the constant of this one switches. Remember this one is if you connect this one all time, then what happened? This inductor we have like a short circuit in DC.
Yeah, still,
In
sir.
DC, and this capacitor also we have a open circuit in DC. The same as V in, same as the V output. You can't buck the voltage up input voltage. To buck the input, to work to do the work of an inductor and capacitor, then you must have an inject an AC signal. You behave, do like that, and it is behave like AC. That's why you do the switching on off like that. Same thing you apply in transformer also. On off. If you give a pulse, you know about the pulse transformer is coming in the market. I think you study also.
Yes.
It is also the pulse transformers. Same working. If you change the flux of transformer, then transformer will work. So the Faraday law. Same thing apply up inductor also. You can't give a constant input voltage to the constant inductor. You should change the voltage of inductor to change the fluxes. Flux depending on the voltage.
Yes, sir.
No d phi by dt is equal to V voltage. This one will be induced voltage, and inductor voltage L di by dt, and I is I directly proportional to phi fluxes. Yeah, you can say flux directly proportional to current. If you current vary here, it means if you voltage vary, di by dt directly proportional to the voltage VL. Di by dt is directly proportional to voltage VL. If you vary the VL, it means you vary the current di by dt. If you vary the current, then flux will be vary. The flux will vary, then conductor will be work. But if you change it in the flux, then it means you have some AC quantity in the conductor current. Then you analyze the AC quantity in such way to control the output voltage, to find the transfer function of the signal. If you have a DC is pure DC system, DC signal, then you can't find the Laplace of this one. Laplace is the same constant. Or we also know about the Fourier analysis. Know about the Fourier analysis? Fourier is says that if you have a waveform like it will not have pure DC, it will not have pure AC. AC it means like a sinusoidal comparison, like a positive negative. This one is a sinusoidal. You can say this one is AC signal. This one is a DC is a pure constant, constant voltage. A DC signal. If you have not a DC, pure DC, if you have not a pure AC, it means to have some AC and DC quantity both. For analysis, say like xt is equal to A naught, a DC signal, plus of summation of harmonics. So say n is equal to 1, 2 like that to infinity. An cos n omega naught t plus Bn sin n omega naught t. And this one is the AC signal. It means the DC and AC both included. If you have not a pure DC, you have not a pure AC. Then you can retain as the DC and AC signal. It means this signal is however some AC and DC quantity. DC quantity is meant average of this one is the DC quantity, and ripple of this one is the AC quantity. That's why you realize this one and control the switches like that. This is known as, it's also known as the small signal analysis of perturbation of the quantities. To analyze this one, first of all find the input the inductor voltage in the on time and off time. After that the inductor current, because we have only two energy storing element to analyze this one. Only capacitor and inductor will not work on DC, it will work on AC. That's why focusing on this two element only, inductor current and capacitor voltage, and realize this one. You know about buck converter? Once switch is on, voltage is Vs minus of V naught, written as a DIL by dt, Vs minus of V naught, and current IC is equal to IL minus of I naught. IC is equal to C dVc by dt, IL minus of I naught, and switch is off. Inductor current is minus of V naught, voltage, and L DIL by dt minus of V naught, and IC is same, IL minus of I naught. It means C dVc by dt is IL minus of I naught. To find the transfer function, I am doing the small signal analysis. Take voltage, inductor voltage in one equation and capacitor voltage, capacitor current in one equation. So if you take a DIL di by dt, if you want to take in one equation, it means the switch is on, then simply multiply by f due to this. And it means this one switch is on, then this one find Vs minus V naught, plus the switch is off, 1 minus D minus of V naught. The switch is off, switch is on, then this one is fine, and switch is off, then this one is fine. You can take a D is equal to 1, then this one will be 0, this one is fine, so D is equal to 0, then this one is 0, this one is fine, minus V naught, same as. Then you can return as DIL by dt is equal to dVs minus D naught on plus D naught, dV naught is cancelled out. Only find we will find only V naught. To solve this one, equation number first. Same thing apply for current, dVc by dt, capacitor current, Same thing of IL minus half I naught in both condition. Then you written as D into IL minus half I naught plus 1 minus D IL minus half I naught. Then to find that IL minus half I naught. I naught you can return as V output by
Sir,
yes.
sir, your writings is not visible.
Okay.
So that CDV it is there.
Wait. It's okay.
Yes, sir.
I
Now it is.
yeah consider current looking IL minus I naught really cancelled out. Then I naught written as the V output by R and V output is same as the VC capacitor voltage because of the both are connected in the parallel. And written as dVc divided by of dt is equal to IL minus of Vc divided by R. We have a two equation. Then apply a perturbation. Look into the circuit. If you connect here to the source, then V in constant supply. Inductor, we want to design the inductor, then you can't change this one. Capacitor, you place this one. R1 once is the R depending on the load. Then ripple coming in the only here IL current and capacitor voltage, and while you will change only the switch duty ratio. You can change the duty ratio to control the output voltage only. The remaining all portion is constant. V in connected to the source, you can't change to control the output voltage. Then only duty ratio can change. Then what is the perturbation occurs here? Then IL, it means there are some this one is some average current of IR and some perturbation of ripple this one. Same as the VC capacitor voltage, some average capacitor voltage plus of some perturbation. Duty ratio, some duty ratio, the constant duty ratio, and changes in duty ratio to control the output voltage.
So it is again stuck.
Yes.
It is again not visible.
Oh, okay, there are also some part.
Sir, sir,
Yes.
it seems to be visible to other persons. Yeah, the other person is saying it is visible. You can continue, sir. It seems it's a problem is with me, I think.
There are some technical issue connected out.
Sir, no, sir. Other person are saying that it is good to him.
Okay. Okay. This is okay.
Yes, sir.
So we can apply perturbation in inductor current, capacitor voltage, and duty cycle. You can change only this one. So ripple is coming in the inductor current and capacitor voltage and duty ratio to control the output voltage. Then what in the question? From equation number first, same thing you can apply IL and D, L, D, IL replaced by this one IL capital IL dt plus L small IL cap divided by F dt is equal to dVs. It means D plus D cap Vs minus of V naught, V naught replaced by Vc capital Vc minus of Vc cap average of this one, and this one is the total basis. IL by dt plus L dIL by dt is equal to dVs plus D cap Vs minus of Vc minus Vc cap. And this one is the same. And in the equation, if you apply Vc V naught is like a Vc dVs minus Vc dVs minus Vc is same as L dIL dt. Then this will be cancelled out. We will find only L dIL by dt. And what is dIL by dt cap? So dIL cap divided by dt is equal to d by dV. So this one d cap Vs by L minus of 1 by L into Vc cap. This one equation number third. Same thing apply for equation number 4. Sorry, second. This one IL cap and Vc cap. To apply this one to find dVc cap divided by f dt is equal to IL cap minus of Vc cap by R. If you divide by C, this one by C, this one by RC. We have two equation.
So the small signal variables, this IL cap and VC cap. Sir,
Yes, yes, sir.
the small signal variables, IL cap and VC cap.
Yeah. Let's change it. This one. Perturbation will
Sir,
be changed.
can these variables only be taken as small signal variables? The differential term. Uh, that IL, VC, and
Well,
uh,
this one is where the state. You can take as a state of BC and IL like that.
mhm.
That's why you have a two equation. From two equation, you can written as in state spacial representation like IL. IL cap dot. You can written this one VC cap dot written. IL cap, VC cap. This one for the control of converter.
Okay.
You can written as this one is IL is not present in this equation. This one is 0. VC is there. Then minus of 1 by L. Then this one is IL is there. 1 by C. This one is VC is minus 1 by RC component. VC component is minus of 1 by RC. And D component is here on C. VS by R. This one will be 0 because D cap not present here. And what is the output voltage? Output voltage same as VC cap output. Inductor capacitor voltage. The output you can represent as like 0, 1 for IL cap and VC cap. This one is the matrix A, this one matrix B, this one matrix 6. A matrix is represented the states of plant. This one is the B matrix is the input, represented as the input. C matrix represented as the output. If you want to find a transfer function from a state space analysis, so you can find a transfer function directly by apply S I minus of A inverse into B, where C is this matrix, B is the input matrix, Si minus A is this one. If you apply this one, you can find a transfer function of buck converter. Correct? S minus of A, where is I is in identity matrix of 2 cross 2 matrix. And this one is S 0 0 S. So the minus of A minus of A is equal to 0 minus 1 by L 1 by C minus 1 by RC. Find it S 1 by L minus 1 by C S plus 1 by RC. Then what will be the inverse of this one? Cofactor matrix into divided by of determinant of this one. Cofactor matrix is for 2 plus 2 matrix, so simply replace of this two quantity as 1 by RC and change the sign of this one, minus 1 by L and 1 by C, here is S. Then what is the determinant of this one? S plus 1 by RC minus plus 1 by LC. S 1 by RC minus 1 by L 1 by C S into this one is a S square plus S by RC plus, so this one is an S minus of this one plus 1 by LC. transfer function. Then transfer function is output voltage divided by input. Input is duty ratio. You can change only duty ratio as an input, because of here B input is represented as the duty cycle perturbation. Output is shown VC, and the output is V output divided by D cap is the transfer function. C into Si minus inverse into B, 0 into 1. Si minus 1 inverse, it means 1 divided by RC minus 1 by L, 1 by C, S into 1 divided by S square plus S divided by RC plus 1 by LC. B is Vs by L into 0. Multiplication of this one, go to here 0, this one 1 by C, and this one equal to 0, and S, take as a comma here, find this Vs by L, so 0 into 1 divided by S square plus S by RC, so 1 by LC. Multiply of this one, then we find Vs divided by LC divided by so 0 S square plus S divided by RC plus 1 by LC. Take LC as a common, 1 by LC, take 1 by LC as a common, and we find finally Vs divided by 1 plus S into L by R plus S square into LC. This is the transfer function of buck converter. Vs divided by 1 plus S L by R plus S square into LC. To keep in mind of this one transfer function, you can design the compensator or controller for the converter to find the constant output voltage. To find the transfer function, then you can find the gain of this one, phase and bandwidth. After that, we will design simply.
Sir,
Yes.
in the transfer function, how we are saying that the input is duty cycle? We are at the denominator we are writing decap.
Yeah, whatever in B matrix. This one is the input matrix, na?
Okay.
Input matrix, that's what you know about x dot is equal to ax plus bu. Then what is bu? U is the input, and y is equal to cx, where x is the state of the system. Then state is only two state. We have a inductor current and capacitor voltage. Because only two is the varies in your system. IL into Vc. This is only
Who
for
are
the
the
energy storing element also. Then you can take as a state of this one. Then this only you can drive, you can find changes of this one, dIL by dt like this one. You can find only this one if you will this one will change. And from duty ratio, this one is the input. You can give in the input like if design any converter, then what is the our input and output? V in is the input voltage, it's okay. But once you give the input, then this will be constant. You can't change this one, na? You have to maintain the output voltage. And how you maintain? You have only one quantity to change the duty ratio. Then duty ratio behave like a input. circuit of this
Sir,
one. Yes.
that initially we have you have drawn on graph that non-linear curve we are taking as the intervals of linear curve.
Yes. Yes. Yes.
Uh, Sir, can you tell how this wave and the final equation we got that ax plus b is related? Uh,
This one is called the
is,
linear transform. Linear, na state space analysis. If you take a state space analysis of any system, it means this will is a linear system. After that, you can realize the system, whole system. This
so,
whole for only linear system. If you convert the system in that representation
uh,
like that, that means this one is the linear. You can apply a control of this, and you can design the control for this.
sir, there are several linear segments in that nonlinear curve.
Yes, yes.
Uh, will this is this model applicable to all the linear segments of the nonlinear curve?
Yeah, you can apply, but some type of a non-linear system, you can't change the directly for the linearly only for checking the one state like that.
Okay.
This one represent only when the system will be changed in very less amount of
Oh,
deperturbation is very less.
okay.
That's why you can take as a linear of this one. You know, analyze the system as a linear. Because of non-linear controlling is the very difficult to control the non-linear system. And every controller uses the convert the non-linear to the linear system. There are several methods like Lagrange method. You know about the Lagrange series.
Yes, sir.
Lagrangian series. No, e power x is equal to 1 minus x minus x square by 2 factorial like that.
Oh,
1 plus this one minus that means this one alternative. Then this one is a
mm,
nonlinear. E power x is the nonlinear function. This one is
yes.
like that.
Mm,
But if you take only this term, 1 minus x,
oh,
then this will be the linear. Na?
yes.
If you have a x square term, then x square is the non-linear. X square we have like that. But
Yes.
x is like that. Then x is a linear term. So take only the first order system. First term. Only x term, not x square. Leave this all of term. There are some also limitation. And what is the value of x? X should be less than a 1 like that. Then you can apply. If your x is greater than 1, suppose this one is greater than what 1, then you expand this one. You can leave this one because this is a more term, more quantity, more value with respect to the x.
Mm,
No, if you have a e power x, yeah, like that, if you 1 minus x minus of x square plus of x square equal to 2, if this one is the less than this one, less this one is a 2, e to power minus of 2, then 1 minus 2, okay, minus of x square, this is a 4. Then you can't remove,
neglect
you
this.
can't neglect this term. You can neglect only when the x is less than 1, like a 0.1. Point
Mm,
is square is 0.001
mm,
divided by of 2 factor 2. This is also, this is a very less, and next term like x cube is also very less. Then you can neglect after all term, take only this one 1 by x 1 plus 1 minus x like that. Like if you want to realize that, if you take a e key power minus of 0.2, okay, then what happened? 1 minus 0.2 plus 0.2 square divided by 2 factorial, or 2 factorial, no, exactly. Let's take this one. Then what will the value of this one? calculate from a calculator like e to power minus of 0.2. This is 0.8187.
Mm.
Then what is
Yes, sir.
this one? This one 0.8.
Ah,
Then you can calculate this in all term.
okay.
This is a Lagrange series, a Taylor series, na?
Mm.
Taylor series
Okay.
expansion. This is also says the no, convert the non-linear term to the linear term, like a sin x also, sin x, cos x, tan x, all of you can convert into linear term. Yeah,
So only Taylor series is used to convert nonlinear to linear.
yeah, but there is some limitation, na? Like x should be less than 1.
Okay. So that similar limitations exist here also in our control system also.
Yes, yes, yes. There is a solar system.
Okay.
Okay,
Here the okay, the duty cycle change should be within a
the limit,
certain limit.
within the limit.
Okay.
Okay, I am stopping here.
Okay, sir.